everybody. It's time for our sweetly balanced equations lab. I'm Mrs. Harris over here on this side, and hi guys. Ms. Anderchek is over on the other side with the document camera so that we can do both parts of this lab. I'm going to be showing you what you need to be writing, and she's going to be showing you what you need to be doing. So hopefully you have what you need. I gave you a materials list, looked like this last week. I was able to spend $8 and get lots, like more than I needed. So the hope is that you can spend like $3, $4, less than $5 and get everything that you need to do this lab, and that maybe you have some of these things already. But it's just fun. It gives you a chance to have a visual representation of what the atoms and molecules look like, and then you get to eat candy when you're done. So, can't be bad. When you go into the folder, you're going to be forced to make a copy of the lab. So up in the top where it says copy of, I really would appreciate it if you would replace copy of with your name, your first and last name, because that makes it a lot easier to find when you've shared it back with me. And then of course, you can put your name on the document, but if you put your name in the title, that's really that's the cat's meow for me, because that means I can find it a lot more easily. All right, so this is what it looks like. You should be looking at the same thing after having made your copy. Basically, the items that you need are, if you would show the plus signs, you're going to need 2 plus signs and 1 equal sign. So I do recommend putting these on separate paper and not writing them on the paper that you're using for the lab. Because you're going to need varying amounts and space and everything. And so it's just best to have ones that you can move around. Then you're going to need the candy. I don't think we can zoom out enough for you to see the candy we've got. Oh, there we go. So you need marshmallows. You're going to need 12 marshmallows. You're going to need either yellow Reese's or yellow M&Ms. You're going to need blue Reese's. Blue M&Ms. There are no blue Reese's. You're going to need green M&Ms. You're going to need orange, either Reese's or M&Ms, and brown, either Reese's or M&Ms. And the numbers of all of those that you're getting, and of course our Hershey Kisses. Yes, how could I forget our iron? So you're a good fan of. So the materials list will tell you how many you need of each of those things. And also the front of this page will. So, of course, because this is edible candy and you want to be able to eat this when you're done, wash your hands before you start doing the lab. Make sure you do this on a clean sheet of paper in a clean place so that when you're done, you can actually eat the candy. Yeah, okay. So, normally I would display, I would ask, you'd be working in pairs, and I would ask one of you to do the reactant side and one of you to do the product side, and each of these would be divided in half because each of you would get half the candy. But because of the corona, we can't do that. Everybody's got to have their own. So that's why everything is doubled from what it normally would be. But bear with us as we adapt this to something new. Normally, I would have one person have this page showing so that you can see what everything is. And then the other person would have the actual equation showing on your page. On your page. But that's not really doable. So I would recommend either that you take a piece of paper and label everything or write it down someplace. I'm going to be scrolling back and forth, so hopefully maybe that'll help you. You also can pause the video at times and things like that. So it doesn't go up any higher. That's what I'm saying. Like that's the highest it goes. Okay. Okay, so let's start with this first one. So we've got sodium plus chlorine, Cl2 equals NaCl. So I'm going to flip over so you can see what that would look like.
We'll need our plus in there. And then we're going to need our sodium molecule. We have 1 sodium molecule. Then we have our chlorine molecule, which is 2 chlorines. And then we have our, on the product side, we have our sodium chloride. Remember, this is sodium chloride, so it has to come in as 1 molecule right there, sodium chloride. Okay, so we have chlorine, sodium, chlorine, and sodium chloride.
Okay, so now we can tell by looking at this that it is not balanced because we've got 2 yellows on the reactant side, but only 1 on the product side. So that's where we have to start. We need more yellows. And we can't just add a single yellow. You have to add a whole molecule of sodium chloride. So we're going to put in a whole molecule, 1 yellow and 1 blue. Well, now that we have 2 blues on the product side, we need 2 blues on the reactant side. Fortunately, the chlorine is by itself, so it's easy to just add 1 more chlorine, and now we're balanced. Sodium, oh, my bad. It's Na1Cl2. Sorry, sodium's blue, chlorine's yellow. But anyway, so we have 2 sodiums, 1 Cl2 molecule, and then 2 salts. So how would we put that into the page? We've got to put in our coefficients. So we have 2 sodiums, so we're going to put a coefficient of 2. Then we didn't have to change anything here. It's a coefficient of 1. And so most of the time, now there's going to be some activities that are done where you have to put a 1 here for the activity. Like JLab, for example, when you do review on JLabs, you have to put the 1 there to make the thing work. But for normal purposes, if no coefficient, just like no subscript means 1, no coefficient means 1. So we're going to leave that blank. And then we have a coefficient of 2 here. Now, if you were here in the class, I would look around, see that everybody had it done, and I would initial your paper. So that's what that means. It doesn't mean you need to write your initials there. That's for my initials or Ms. Andrzejczyk's initials if we were actually in class to go around and give you the grades. Okay, moving on to the next one.
All right, so our next one is we have sodium. Okay, so we have sodium by itself. And then we have H2O. So we have hydrogen. Now our hydrogen is marshmallows, so see me place them there. And oxygen. And remember, that's 1 molecule, H2O. So that's our 1 molecule of water. And then on our product side, we have NaOH. So we have NaOH. So we have sodium, and we have oxygen, and we have a hydrogen. And that is 1 molecule. Then we have our plus. And 1 more molecule of H2. That's our marshmallows. Can you see me place them there at the end? H2.
All right, so obviously this is unbalanced. We have 2 hydrogens on the reactant side and 3 total hydrogens on the product side. Everything else is balanced. 1 blue, 1 blue, 1 orange, 1 orange. So hydrogen's where we have to start. So the only way to get more hydrogens on the reactant side is to add another water molecule. So we have to add a whole nother water molecule, which is two whites and 1 orange. Okay, well now we have 2 oranges on the reactant side, and we need to have 2 oranges on the products side. So again, we can't just add 1 orange. We have to add a whole molecule of sodium hydroxide. So 1 marshmallow, 1 blue, 1 orange to get that molecule of sodium hydroxide. All right, so now we have 2 blues on the product side and only 1 blue on the reactant side. So we've got to add another blue. But what's great is that blue's by itself. So we don't have to think about other stuff. We can just add a second blue. And look at that. We are balanced. There's 2 blues on the reactants. There's 2 blues on the products. There's 2 oranges, 2 oranges. And then 4 hydrogens, 4 white marshmallows on the products, 4 on the reactants. Okay, all right, so now we've got to see how we would put that on the page. All right, so we had 2 sodiums, 2 waters, 2 sodium hydroxides, and then again, we didn't change this one. It stayed the same. So it would be 1, but we don't really have to write the 1. No coefficient is left blank. All right, I want you to pause right now, and I want you to see Well, don't pause yet. Wait till you get the instructions. I want you to see if you can set up the next one. Just set it up. Don't try to solve it. Just set it up. I want you to see if you can set it up correctly. So see if you can get the candy laid out correctly for number 3. Pause it and then unpause when you think you're ready to check it. Okay, so does yours look like this? Ms. Andrzejczyk, what do we have?
We have our carbon monoxide, nitrous oxide, okay, nitrogen and oxygen. And then on our product side, we have our carbon dioxide, and our nitrogen. Remember that there's 2 of those in 2. All right, but that's not balanced.
So if you are willing, pause again now and try to solve it. If not, I understand it's only the 3rd one. Stay with us, solve it with us. But if you want to give it a shot, pause right now, see if you can solve it, and then come back. Test yourself, okay? All right, so here we go. All right, we've got 2 nitrogens on the product side, and we only have 1 on the reactant side. So we're going to add another NO, another nitrous oxide molecule. So 1 green and 1 orange, because we know we can't just add green. All right, now we've got 3 oranges on the reactant side and only 2 on the product side. So we've got to add another. But again, we can't just add 1 orange. We have to add a whole molecule of carbon dioxide. So 1 brown and 2 oranges. Oh, look at that. We now have 2 browns on the product side. So we need 2 browns on the reactant side. So we need to add another whole molecule of carbon monoxide. And what? It worked out. We have 2 browns, 2 browns, 2 greens, 2 greens, 4 orange, 4 orange. It balanced out. Okay, so we would write 2 carbon dioxide, 2 nitrous oxide, 2 carbon dioxide, and then again our N2 we left alone. Okay, again, pause, set it up, see if you can figure it out. Last time.
See there, letters.
Okay, welcome back. Here's the next one.
All right, so number 4 we have Fe, 2O3 plus carbon monoxide, CO. Then we have on our products, we have iron, Fe, and then we have carbon dioxide, CO2.
All right, pause, see if you can solve it. Welcome back. Here's the answer. Okay, so we've got 4 oranges, 4 oxygens on the reactant side. So that's the first place I would start over there. We need 4, or at least to shoot for 4 oranges, oxygens on the product side. So we've got to add a whole carbon dioxide molecule to the product side. Oh, darn. It did fix our orange problem, but it messed us up with the brown. We now have 2 carbon on the product side and only 1 on the reactant side. So we've got to add another carbon monoxide molecule on the reactant side to balance that out. Oh, shucks. That messed up our orange, our oxygen. So we've now got to add another carbon dioxide. Haven't you missed school? Bells and good stuff. Anyway, we add another carbon dioxide molecule, but that gave us another carbon, another brown. So what do? We add another carbon monoxide molecule on the reactant side. And look what happened. Oh, it's balanced. We have, oh, it's not balanced though. What are we missing, Ms. Andrzejczyk? What's the problem?
We only have 1.
Yeah, iron. We only have 1 silver, so we need that second silver.
Lucky for us, iron is by itself. That makes it pretty easy.
There we go. Okay, so now we're balanced. We have 2 silver, 2 silver. And see, this is why we do this, people. You check yourself. Even when you think you have it right, you check and make sure you have everything matching on the same side so you catch those little mistakes. Anyway, 3 brown, 3 brown, 6 orange, 6 orange. It's balanced. So now we've got to put that onto our sheet here. So this stays empty because it was 1. It didn't change. But we have 3 carbon monoxides. We had 2 irons, and we had 3 carbon dioxides. All right, again, pause and set up the next one. See if you can figure it out. All right, let's check and see if you got it laid out correctly.
All right, so we have our carbon. We have Fe2O3 COFE. So guys, even if you don't know the names of these, we can still do this. So we have our carbon, we have our iron and 3 oxygen, we have our carbon monoxide, and we have our iron.
The iron and 3 oxygen is iron oxide, and there's actually, or ferrous oxide, there's actually 2 ferrous oxides. There's ferrous oxide 2 and there's ferrous oxide 3. So there is a type of ferrous oxide that has 2 irons, and then there's another type that has 3 irons.
We're going with this one.
Well, we're going with the easy one. All right, so we have 3 oranges on our reactant side, and we do not have 3 oranges on our product side. So we're going to need to add 2 molecules of carbon monoxide to our product side to even have a chance of getting this balanced. So we're going to go ahead and do that. Now, that gives us the 3 oxygens, but it also gives us 3 carbons. So guess what we got to do to the carbon? We need to add 2 more. We need 3 total. So we now have 3 carbons. And then the only other thing, we've got 2 silvers. So we now need 2 silvers on our product side. So you just need to add another Hershey Kiss. And now that's balanced. 3, 3, 3, 3, 2, 2. Okay. All right. So carbon was 3. This one we didn't change, so you leave it blank. Carbon monoxide was 3, and iron was 2. All right, so if we were in a regular school day, what I would have done next is tell y'all that if you feel like you've got this and it's easy peasy, and for real, did that just happen?
Yeah.
You saw that, right? What in the world? Erase, please. Excuse us, technical difficulties. Okay, so maybe we've got it figured out. We'll see. There's a little red dot there that doesn't want to go away. So normally what I would tell you is if you've got this figured out, you don't even need the candy anymore to figure it out, then for the 5 remaining problems for 6 through 10, oh, I guess that's a separate sheet. Okay, well, for the remaining problems, which will be there for you because I'm going to fix that by the time you have this document. Sorry about that. You're going to use the drawings on the page, and that's fine as an option instead of using the candy. You can eat the candy while you're solving the remaining 5 equations. If you need the candy, if the candy really helped, that's fine. Use the candy. But you need to at least attempt the remaining 5 equations and give those answers. Now, I am going to, the ones that we did for you, the ones that we gave you the answers, they're going to be worth 5 points each. And then the 5 that you're doing on your own are only 1 point each. So it doesn't hurt as badly if you get them wrong because you're doing them on your own. And I understand that you may not understand it. But if I've given you the answer, yeah, I'm going to expect it to be a little better. Okay, so I guess that's it. Ms. Andrzejczyk, anything to add besides crunching on candy? Y'all have a lovely day. Make good decisions. Bye.